Hello and welcome back. In the last video we talked about how to factor simple trinomials, and in this video we're going to be looking at how to factor complex trinomials. So to review what the difference is between simple and complex trinomials, we'll look at some examples. So for simple trinomials we have examples such as x squared plus 7x plus 12 and x squared minus 8x plus 15. In both of those cases we notice that there is no number in front of the x squared. Or we could imagine that the number is 1, in which case we wouldn't show it. With complex trinomials, there is a number in front of the x squared. For example, in these cases we have 2 for 2x squared plus 10x plus 12, and 3 for 3x squared minus 11x plus 10. Okay, so the main difference between simple and complex trinomials is that leading coefficient, that coefficient or number in front of the x squared. So how do we factor complex trinomials? We're going to factor complex trinomials using a technique known as decomposition. So why don't we consider the quadratic equation 2x squared plus 10x plus 12. So the first step that we're going to be taking in decomposition is to multiply the first number, or the number in front of the x squared, by the third number, or the number that comes after the x term. So in this case, we multiply the first number, which is 2, by the third number, which is 12, and we get 2 times 12 is 24. Okay, so we're going to keep in mind that we have that 24 number as we go through this problem. Just as in factoring simple trinomials, in complex trinomials we want two numbers that add up to the number in front of the x. So in this case the number is 10, so we want two numbers that add up to 10. So 1 and 9 add up to 10. 2 and 8 add up to 10, 3 and 7 add up to 10, and 4 and 6 add up to 10. So why don't we keep in mind those four sets of numbers? What we'll do is we'll multiply each of these numbers. So 1 times 9 is equal to 9, 2 times 8 is equal to 16, 3 times 7 is equal to 21, and 4 times 6 is equal to 24. Okay, and we notice that 4 times 6 is equal to 24, which is the same number that we got from multiplying the first number of the quadratic equation by the third number. And that gave us 2 times 12, or 24. So that is the set of numbers that we want. We want two numbers that add up to 10 and multiply to 24, or the product of the first and the third numbers. Once we do that, we can break down or decompose the 10x, or the number in front of the x, to the two numbers that we got. So we got 4 and 6. What we'll do is we'll break down 10x into 4x and 6x. Then we will put brackets around the first two terms and brackets around the last two terms. Okay, and once we do that, we can apply our technique of simple factoring. So with the first set of brackets, we see that the common factor is 2x. So we can factor out the 2x from that expression to get 2x times x plus 2. And with the second bracketed expression, we see that the common factor is 6. So we'll factor out the 6 from that expression to get 6 times x plus 2. And then what we will notice is that we have an x plus 2 in both of the terms. So I can highlight that, and the reason why this is important is because we can actually factor out that expression out of the equation. So we can factor out the x plus 2, and we will be left with x plus 2 times 2x plus 6. And that is our factored form of the quadratic equation. So just to review, we multiply the first number by the third number to get a new number, and then we look for two numbers that add up to the number in front of the x and multiply to give us that new number. After that, we can use the numbers that we get to break down or decompose the number in front of the x to those two numbers. Then we put brackets around the first two terms and the last two terms, and then we do some simple factoring and we get to our factored form. So I'll do one more example. This is definitely the kind of thing that you'll become very comfortable with as you practice this a bit on your own. So in this case, once again, we'll multiply the first number by the third number. 3 times 10 will give us 30. And once again, we will consider the number combinations that add up to negative 11. So we can do negative 1 and negative 10, negative 2 and negative 9, negative 3 and negative 8, negative 4 and negative 7, and negative 5 and negative 6. So negative 1 plus negative 10 is negative 11. Same thing for negative 2 plus negative 9. That gives us negative 11, and so do the other three number combinations. Once again, we can multiply each of these pairs of numbers. So negative 1 times negative 10 is 10. Negative 2 times negative 9 is 18. Negative 3 times negative 8 is 24. Negative 4 times negative 7 is 28. And negative 5 times negative 6 is 30. So the two numbers that add up to negative 11 and multiply to give us 30 are negative 5 and negative 6. Okay, once again, once we have determined those two numbers, we can decompose the negative 11x into negative 5 and negative 6. So we will have 3x squared minus 6x plus negative 5x plus 10. Once again, we can put brackets around the first two terms and brackets around the last two terms. And then we will factor out the common factor from each of these expressions. So for the first expression, we can factor out the 3x. That will give us 3x times x minus 2. For the second expression, we can factor out the negative 5. That will give us negative 5 times x minus 2. Then we're adding a negative number, so we can rewrite this entire expression as 3x times x minus 2 minus 5 times x minus 2. Once again, we notice that we have x minus 2 in both of the terms, so we can factor that out. And we will have x minus 2 times 3x minus 5. So that is our factored form. So really, this technique of decomposition combines techniques that we talked about from simple factoring and factoring simple trinomials. So now that we have established the techniques to factor any kind of quadratic equation, we can now take a look at what the factored form is actually used for, and how we can use it to have an easier time sketching a parabola. So that is something that we will go over in the next video, but for now, as always, thanks for watching.